For 7, this is actually off of an AP exam. You're taking the derivative with respect to x of x to the negative 3 minus x to the negative 1 plus x to the 2. That's the same. So I make the negative exponents so I don't have fractions anymore, so I don't have to do a quotient rule a bunch of times. And then I plug in a negative 2 and I'm done.
What?
Wait. Explain that.
Oh, you plug in negative.
To recap, I know I went a little fast on that one. Instead of writing 1 over x to the 3, I wrote x to the negative 3. I moved the x to the top, and I make the 3 a negative. I changed the sign. I did the same thing with this x. I put this one on top, so it says x to the negative 1, and then I have x to the 2. So I take the derivative of this. I'm going to do the power rule for that one, and then for that one. And then when I'm done, I'm going to plug in negative 2, and that's how you're going to get the answer in the end. Okay? So if we use the same strategy here for this one, this would be 1 over x to the 1/2 power. How would I make this not a fraction? This is the same as x to the negative 1/2 power. Now, can you take the derivative of that? Yeah. So if I take the derivative of that, you're going to get negative 1 over 2 x to the negative 3 over 2. This is our derivative. And I think that's all it wants you to do, right? All right, so let's make it not a negative exponent, just in case, so we know how to manipulate. It'd be negative 1 over 2, and I'm going to put the x on the bottom with it. Okay, and then you could go even farther. Instead of writing a 2, a 1/2 right there, you can go 2 square root of x raised to the 3rd power. Or that 3rd power can go outside of the square root. It doesn't matter. But all these answers are correct. This is correct, this is correct, this is correct. Okay, you got to choose for number 11 if you're going to do product rule or quotient rule. If you just leave it like this, you're going to do the quotient rule. If you take that x and put them out in front like this, and then x to the negative 1 times tangent x, you can use the product rule. So this one is the same as this. So what do you want to do? You guys want to do a quotient rule or you guys want to do a product rule? Product rule sounds better to me as well. So this equals, if I'm taking a derivative of this, I'm going to take the derivative of that. I'm going to get negative 1 x to the negative 2 times tangent x plus, now since I took the derivative of the first one, multiply it times the second. Now I take the derivative of the second one, multiply it times the first. And so the first one I'm just going to put negative x to the negative 1. And then the derivative of tangent is secant squared x. Now I like to look at this like secant squared, like that. It's easier to look at that way. Now when I plug in pi over 4, life seems easier. So then you plug in pi over 4 and you get jiggy with it. Okay, so this is going to be tangent. Actually, let's just plug it all in. So you have negative pi over 4 raised to the negative 2 power times, what's tangent of pi over 4? That's just 1, right? Okay, plus, then I have pi over 4 raised to the negative 1 power times, okay, do we remember what secant of pi over 4 is? Secant, okay, think of a sine of pi over 4. No, not sine, cosine. What's cosine of pi over 4? Cosine of pi over 4 is rad 2 over 2. Secant is the reciprocal, so we just have to flip that. So we get 2 over rad 2, and then we're going to square it. So this guy would simplify. If you multiply top and bottom by rad 2, it would be rad 2, and that radical will go away, and then these 2's would cancel out. So it's just rad 2. So let's finish this. Okay, this has a negative 2 power, so we have negative 4 over pi, and I'm going to raise that to the second power, plus, I don't need this 1 anymore because you didn't do anything, and I have 4 over pi right here for that one, and then this, what is rad 2 squared? That's just a 2. All right, we're getting more simple and more simple. It's looking nicer. We have negative 16 over pi raised to the second power plus, what is that, 8 over pi? I'm not sure how far the answer goes. I don't know if they found common denominators here. So I multiply the top and bottom by pi's, and I get, let's see, I would write it like this. 8 pi minus 16 over pi squared.
That's exactly the answer.
Sweet.
Wait,
Okay, now for you quotient rule lovers. What if you're like, no, I just want to do a quotient rule? Okay, if you want to do a quotient rule, you would first take the derivative of the top. So that would be secant squared x, and then you would multiply it times the bottom, minus the derivative of the bottom. What's the derivative of x? 1, and then times the top, so tangent x. Then I take that all and I divide it by the bottom squared. Once you do that, throw in pi over 4. Don't even bother simplifying unless you just had to find f prime. But here you're finding f prime of pi over 4. So don't even simplify. Just plug in the pi over 4 and get busy with it. So if I get pi over 4 right here, I plug that into my secant. What is cosine of pi over 4?
Rad 2.
That's right. We did this, huh? Rad 2 over 2. And then if I flip this to make it my secant, it's going to be just a rad 2. So we get rad 2, and we square it. And we're multiplying that times pi over 4 minus. And then what was tangent of pi over 4?
1.
Just 1. And then on the bottom we have pi over 4 squared. So I just plugged in the pi over 4 to all of them. Things are looking prettier already. This is just going to be a 2. 2 times this is going to be a pi over 2. Because you get 2 pi over 4. That simplifies to just pi over 2. So I get pi over 2 minus 1 divided by pi squared over 4. No, not 4, 16. Right? Because we have to go pi times pi, 4 times 4. All right, you guys all cool so far? How come it doesn't look the same? Well, this says this divided by this, which is the same as multiplying by the reciprocal. So instead of having this down here, I can multiply by 16 over pi squared. And so if I distribute that, if I go this times this, this times this, you'll get 16 pi over, what is that, 2? 2 pi squared minus 16 over pi squared. Oh, can I simplify this guy? What can I take out of both of those? I could take a 2 out of both of those. And now if I combine them, I have 8 pi minus 16 over pi squared. Same answer, 2 different ways. Okay, so change this to a 1/2 power. So we have 3x raised to the 1/2 power.
Then you do L power rule.
Yeah, so because we have a function, that 3x is inside the 1/2 power. That's a function inside of a function. Our outside function would be x to the 1/2. Yeah, I got to do chain rule. And then I have the inside function, which is 3x. So there's an outside function and inside function. That means it's chain rule time, people. All right, so what we're going to do is we're first going to take the derivative of this 1/2. So we drop the 1/2. We keep the 3x inside, and then we take 1 away from the 1/2, like so. Then we multiply it times the derivative of the inside function. My inside function is 3x, so what is that? What's the derivative of 3x?
3.
Just a 3. And so if I clean this up a little bit, we would have 1/2 times 3x to the negative 1/2 times 3, which would, I'm just going to put on top of the fraction because 1/2 times 3 would be 3 over 2. Then, to get rid of that 1/2 power, I mean, you don't have to do this because we get to plug in the 3, but I'm going to simplify it even more. We have 3 over 2, and I'm going to put that 3 over x on the bottom and make it a positive 1/2. And what is positive 1/2? How else can you write positive 1/2? As a square root. So I can just put this as a square root right here. So now let's plug in that 3. If I plug in that 3, we have 3 over 2 times.
Wait, I'm confused. How did you get from 3 over 2 times 3 to the x to the negative 1/2 to that?
Just pause for a second. Let's go back to this really quick. To get rid of that negative exponent, I have 3 over 2 times this. So here's 3 over 2. I'm multiplying it times that. But look what I did. I put it on the bottom of a fraction so that the 1/2 power becomes positive. And now when it says positive, I can make this into a square root sign instead of a 1/2 power. Because the 1 is the power and the 2 is the root. And since it's a 2, it's a square root. So I can write that like this. I multiply straight across to get 2 rad 3x. And so square root of 9 would be 3. 3 times 2 is 6. So you have 3 over 6, which equals 1/2.
That is the right answer.
Sure, Patey.